Okay, good morning. Can you all hear me? Testing, testing. Good morning. Can you all hear me? Yep. All right.
Yes.
Well, thank you. So, yep, let's start with today's sessions. Okay, as I think some of your classmates are not joining us also. So for those who are not joining, you let them know that they can watch back the video if they miss out the classes. Some of them already joined my other classes too. So we will begin our session now. And don't worry about your attendance. It will be automatically allocated for you. Okay. So today we'll be talking we'll be talking on topic 6 on interest rates and bond valuation. So it's pretty much the continuation of last week's tutorial. So last week we talked about PVA. All right. We talked about the PVA formula. This is what we see last week. So today there's an extra to it, which is this section. So this whole thing is for bond valuation purposes. This extra, it's included here for bond valuation purposes. All right, this is the formula for bond valuation. So let's begin with some theory questions and we go through it and see what it's about. So when you look at the question here, the first one, company pays rating agencies such as Moody and S&P to rate their bonds, and the cost can be substantial. However, companies are not required to have their bonds rated in the first place. Doing so is strictly voluntary. Why do you think they do it? So, what a weird situation, right? You need to pay to be rated, but you are not compulsory to do it. All right. So why do you want to do that then? They're telling you companies are paying rating agencies to be rated. Okay. They are not required to do so, but they are doing that. So very simple. They are doing this because there is a purpose. So the purpose here is two reasons. Number one, unrated bond hard to sell. Okay. Unrated bond hard to sell. All right. Number two, some large investors can only invest in rated bonds. So the reason company choose to pay to get rated is for these two reasons. Number one, unrated bond hard to sell. Number two, large investor can only invest in rated bonds. All right, so this is so straightforward. This is the two major point why they choose to be rated. Next. Next question, they are separated into three parts. Okay, so the first part is, what is the relationship between the price of a bond and its yield to maturity? So first of all, what is the relationship between price of a bond and its YTM? So what is YTM first? YTM is yield to maturity, or also known as your interest per year. Okay, so in your bond timeline 0, 1, 2, 3, until the maturity here, every year or every period, you'll be receiving payment. And you'll be receiving payment until maturity years or until the end of the period. So for bond, you must remember you will have a FV or your face value of $1,000. This is fixed. Okay, at the end of the maturity, your bond will get back $1,000. This is the value of the bond. This is what we call the par value. Okay, so PV is over here. PV here, it's a bond price. Now, the question I'm asking you, what is the relationship between this one and this one? Okay, so basically, very simple. Listen carefully. Bond price is actually the present value when discounting all the future cash flow back to time 0. Okay, and YTM is the discounting interest rate. All right, so the relationship between bond price and YTM is the bond price is actually the present value after deducting all future cash flow, and the interest rate or the YTM used is the discounting factors. So that's to answer part A. Please ask me if you guys have any questions, drop it on the chat or whatsoever. Okay, so this is for part A. Yeah? So the bond price is the discounting of all future cash flow coming in later on in the year until maturity, being discounting backward to today's value. Okay, so you're counting all this money coming in, all right, and then the discounting factor is YTM, discount back to today's value, how much it's worth. Okay, how much is the value? Then, coming to part B, explain why some bonds sell at premium over par value, while other bonds sell at a discount. So what do you know about the relationship between the coupon rate and the YTM for premium bonds? What about for discount bonds and for bonds selling at par value? So this is interesting. So there are actually 3 types of bonds. Premium bonds, discount bonds, and lastly, par bonds. Premium, discount, and par bond. These are the 3 different type of bonds. Okay, so these 3 different type of bonds, they ask you why some can be sold at premium, some will be sold at discount, and what is the relationship between the coupon rate and the YTM. So I told you, at the end of the maturity, your face value is 1,000. Okay, at the end of the bond time, the bond value will be 1,000. Answer for part A. Later I'll repeat. All right, so now coming back to here, the value will be always at $1,000 at the end of the period. Okay, so a premium bond means the present value it's higher than 1,000. So for premium, your present value or your bond price will be more than $1,000. Discount means your present value is less than $1,000. Par bond means your present value equals to $1,000. Okay, this is one criteria. Second one, which is based on part B here, they want you to relate between the coupon rate and YTM. So what is coupon rate? Your payment here, it's derived from the coupon rate multiplied by FV. So the formula is payment equals to coupon rate multiplied by face value, which is $1,000. Okay, so a premium bond will be having a coupon rate more than the yield to maturity. Yield to maturity is your expected return. Okay, so you invested here, the present value, you expected it to grow by how many percent every single year. All right, so if the payout every year is better than the yield to maturity, then this is a premium bond. A discount bond is when the coupon rate less than YTM. That means your yearly return is not as good as your expected return. And lastly, par bond means your yearly return is equally as your expectation. All right, so this is the relationship between coupon rate and YTM. So look at this section clearly. Yeah. Then now back to Hannah's question, asking about part A. So part A, I told you the relationship between bond price and yield to maturity. So bond price is present value. So bond price also means the present value after deducting all future cash flow with YTM. Okay, so the yield to maturity or the IY given here is the discounting interest rate for all your future cash flow back to today's value. Can Hannah?
Can you repeat that?
I just repeated. How many times you need me to repeat?
Sorry.
Okay, so again, so the present value or the bond price here is the discounting of all future cash flow in upcoming period with YTM back to time zero. So just like your PVA last week, when you see that there's a constant money coming in, okay, all this constant money coming in discounting back to time zero at this interest rate. So this bond price is basically that. It's similar like last week, but just that now present value it's bond price, and bond price will have all these payment coming in upcoming period discounted by this value back to time zero, and this 1000 is also discounted back to time zero.
Okay.
Okay.
Yeah.
All right. Then, so we already settled with part A, part B, and now part C. Part C, what is the relationship between current yield and yield to maturity for premium bonds, for discount bonds, for bond selling at par value? So what is this current yield about? What is current yield about? So there's a formula for current yield. So the current yield formula is equivalent to annual coupon payment divided by current bond price. So this is the formula. Again, for current yield. Current yield is annual coupon payment divided by current bond price. All right. So in current yield, what's the relationship with YTM? So current yield is a little bit different from CR. So it's going to be the exact opposite. All right. So for a premium bond, the current yield will be less than YTM. For discount bond, the current yield will be more than YTM. And for par bond, the current yield will also be equal to YTM. So this is the relationship here. Okay, this is the relationship here of current yield and YTM. So from here, this is something that you want to know. All right, this is something that I want to take note. These are characteristic of three different type of bonds. First, you can see that the present value or the selling price or the bond price here will determine what kind of bonds you are. And what kind of bonds you are, you can see whether the current rate, the coupon rate gonna be higher than YTM or less than YTM or equals to YTM. And it also show you about the current yield. So these are the three characteristics of three of these different type of bonds. Ken, any questions so far? Questions? No? Yes? Don't have, huh? Okay. If there's no issues, then I'm gonna move on to the calculation section. All right. So let's try the calculation question here. So first of all, please remember this section. See whether can I. Okay, so you guys just remember this, huh? Then later we might not be able to come back here. I'm gonna clear it off. All right, so now let's start with our question here. Lycan has a 7% coupon bond. Okay, so this Lycan has a 7% coupon bond. So basically 7% is your coupon rate. And then you have left 8 years to maturity. The bonds make annual payment. If the YTM on this bond is 10%, what is the current bond price? So you know, coupon rate is 7%. So you can calculate the payment because payment is equals to coupon rate 0.07 multiplied by the face value. Face value is always 1,000, like I mentioned. Okay, so this payment here will be $70. All right, if you want to put this into a timeline, it will look like this. A bond timeline. So first, you got your PMT at 70. You already got your payment. Then have 8 years left to maturity. So N is 8 years. Payment semi-annually. Sorry, annual payment, not semi. So it's annual, 1 whole year, one time. If YTM on this bond or your IY is YTM, which is 10%. FV, it's always equals to 1,000. Okay, they want you to find the PV. Here, the bond price. So every single period, there will be payment. So your payment here will be 70, 70, 70, 70 until 8 years later, 70. So on the 8 years, the end of 8 years, you'll be receiving $1,000 too. So this whole thing, the YTM or the IY is equals to 10%. Okay. So basically what you're going to do now, you want to discount all this cash flow back to this period. If you are using a scientific calculator, then you need to key in your figure. PV equals to PMT of 70. 1 minus 1 over 1 plus R power of 8 divided by R plus FV discounted back 8 years. So This is where you use your this is where you use your scientific calculator. If you use financial calculator, very simple. Just key in PMT equals to 70, N equals to 8, IY 10%, FV 1000, compute PV. So you get a negative figure here. So based on this question itself, without other information, you see that your CR is 7%. Okay, your CL is 7%, which is lesser than the YTM. So when your coupon rate is less than your YTM, you can already know that this is confirmed gonna be a discount bond. So CR less than 10%, what? So this is one of the characteristics. So this is gonna be a discount bond already. So your PV will definitely be less than $1,000. Now you can cross check. Try to calculate, key into your calculator, see what is the figure that you're gonna get. Okay, you will get 839.95. Financial calculator will give you a negative figure. So now with bond, the negative figure could be explained easier to you. So you can see here. So all of you know that bond is a form of capital financing. So I told you before at the early of the unit that a company could source for capital structure based on debt and equity. So bonds fall under debts. Okay, bonds, loans are all under debts. So what does bonds mean? So bond is basically company are borrowing money from general public. Instead of giving you their stakes or selling off their shares to you, they are borrowing money from individuals. So by borrowing money from individuals, they promise you to give you a confirmed returns, which is the coupon rate here. Okay, which is the coupon rate here. So when you see in this timeline, a negative 839.95 means your initial investment. So if let's say a company borrow money from you, you take out 839.95, you lend it to the company at the promise of 8 years, you get back $1,000. That means the full face value of the bond. And at the same time, every single year you'll be receiving payment. Okay, every single year you'll be receiving payment. So this payment will be depending on the coupon rate. All right, so this is how bonds works. So some of your friends in other tutorial were asking, what is this YTM then? YTM is your expected return. So basically you expect that by investing 839.95 for 8 years, every year you are getting 10%. Okay, so in order to get this 10%, the payment given out to you and the present value that you initially invested need to be adjusted so that this 10% could end up being $1,000 face value, and plus all this incoming cash flow, you can sum it up to get what you expected to get. Okay, so basically the payment or the coupon rate here is the promise from the company to you. I borrow money from you. This is my agreement. I agree to give you 7% every single year. And then on top of that, by end of the last year, I'll pay you the face value, which is $1,000. Can understand, cannot understand on the meaning of bonds now. Anybody? Okay, not okay. Hello. Okay, good. So hopefully you have good understanding about this then, about this whole structure, about what is this about. And yep, if okay, then we move on. So this is to find PV only. Okay, this is to find PV only. So this next question, let's see, what is it about? You look at the next question here. The Smart Choice has 10% coupon bonds on the market with 9 years left to maturity. The bonds makes annual payment. If the bond currently sells for 1145.7, what is the YTM? So this one we straight away draw timeline first. Again, let me draw the timeline to show you first. 9 years to maturity. Okay, you get annual payment. In between, all gonna be same. So at the end of 9 years, you get $1,000. All right, and they are telling you your present value 1145.7. This is negative lah. Okay, your initial investment. So how to make this 11457 grow? Now they're telling you the coupon has a 10%. So your payment is 10% of 1,000. Your payment is 100. Every year you get $100 for 9 years. Okay, and they want you to find the YTM or your IY. Financial calculator, very easy. PMT 100, N equals to 9. PV equals to plus minus 1145.7. FV equals to 1000. Compute IY. No rocket science. So again, when you look at this question here, you can see PV, it's more than 1000. So this is definitely a premium bond. So premium bond means coupon rates will be higher than YTM. So they already tell you coupon rate is 10%. So definitely YTM is less than 10%. Okay, YTM will be less than 10%. So financial calculator will not have any issue here. The issue comes to scientific calculator user. So for those who did not buy the scientific calculator, this is the type of questions that would motivate you to buy the calculator in the end. So if you can recall the formula is PV. PV lah, present value of the bond equals to PMT. 1 minus 1 over 1 plus R power of N over R plus FV 1 plus R power of N. So you got your PV here, 1145.7. PMT 100. Your I, you don't know. FV 1000. Again, I, you don't know. So the problem with this equation is impossible for you to take out the I. So the only way for you to do this is using the trial and error method. So you know that your YTM will be less than the coupon rate. The coupon rate is 10%. So what you could do is you replace one by one. Try to replace what if I equals to 0.09. Can you get this or not? If cannot get, what if I is equal to 0.08? Then you can see, oh, it's a little bit close. Then I is equals to 0.07. Now it's a bit far already. So you know that the answer is between 8 and 7. So you can try what if I equals to 0.075. Closer already. It's between 0.075 and 0.08. What if I if equals to 0.0 7, 7. Then you hit jackpot. So the answer 7.7%. Then you already try and error one by one, key in, you get this figure. The closest to it is 0.077. So you can just put it I equals to 0.077. So this is the try and error method. You need to key in one by one of the figures randomly just to hope that you can hit to get the present value. So this type of question is the one that demotivated students to use the scientific calculator. You end up will be more willing to invest onto a financial calculator, but still doable. Okay, it's gonna be a bit time consuming. So instead of just compute straight away, you do a few more steps further. All right, just to make sure you can get the answers. So are you clear about the trial and error method now? So it's up to you in the end of the day whether you want to use the financial calculator or the scientific calculator. But the scientific calculator will be a little bit challenging and time consuming because you need to estimate. Okay, so please try. Those with financial calculator, you can also explore yourself whether can you get this figure or not. Okay, so practice makes perfect. And before I move on, I just wanted to inform you guys or just to clarify things or just uh, recap. So next week, we will not have any tutorial session because of your independent learning week. Again, so hopefully you guys are learning independently and not playing independently. Then after next week, on the 25th week, 26th of October, you will be having your mid-test during that week. So we will not have tutorial 2. Okay, your mid-test, if I'm not mistaken, will be most likely in the lecture slots. So please reconfirm with your lecturer. Okay, so your mid-test is still the same, no changes on what is coming out. So as being told by your lecturer, just do or just follow her instruction then. All right, so after today's session, we won't be meeting for at least another 2 weeks. So we will be only meeting after that, after the Deepavali week. Okay, so now let's go back to our questions. Question number 5. So these questions telling you that Merton Enterprise has a bonds on the market making annual payment. So this bond got 16 years to maturity and is selling for 963. At this price, the bond yield 7.5%. What must the coupon rate be on Merton's bond? $16 years to maturity. Given to you, selling price is at 963. 963 less than 1,000. You know this is a discount bond for sure. Okay, and the interest yield, the bond yield is 7.5%. Okay, so from here, you can already tell that this is a discount bond. Discount bond, coupon rate lesser than YTM. Okay, so coupon rate definitely need to be lower than this. So payment you don't know, unknown. So you want to find the payment. Okay, the question asking you for coupon rate. Anyhow, you need to find payment first, then only can find coupon rate. Okay, so scientific calculator, this one can do 963 equals to PMT. 1 minus 1 over 1 plus 0.075 power of 16 divided by 0.075 plus 1000 1.075 power of 16. So this one you can get your PMT. Financial calculator, no problem. PV plus minus 963, FV 1000, IY 7.5, and 16 compute payment. Okay, so both sides you will be getting your payment of 70.95. Okay, payment you get 70.95. So as you know, PMT it's equals to coupon rate times your FE. So 70.95 equals to coupon rate times 1000. Coupon rate equals to 70.95 divided by 1000. You get 0.07095 or 7.095%. Simple. So this is definitely smaller than YTM, right? Okay. So this is bond for you. Very easy. Bond only got one formula, nothing else. Okay. The moment you understand the concept of bonds, then it's simple. All right, it's simple. So you just need to know what is bonds, what is the concept of bond, how bond is actually functioning, what is the mechanism behind it, and voila, it's not challenging at all. All right. Any questions up until here? Okay, no from Hena. The rest, anyone having problems? Easy is no problem. Easy, no problem. So got problem, please voice it out. Don't be shy. Okay, don't be shy. All right, then we move on. So bond questions, we put a break to it for a while. We move on to the Fisher equation. So Fisher equation, official equation of Fisher equation is this: 1 plus nominal equals to 1 plus real times 1 plus inflation. So big R is nominal interest rate. Small r is real interest rate. H is inflation. Okay. Second formula. Second formula, R roughly equals to R plus H. So this is very important for the second formula, because second formula here is a rough estimation. Okay, so this is roughly equals to. So let's try with one question first. So an investment offer a 13% total return. 13% total return means your nominal rate is 13%. Bill Bernanke thinks the total return on this investment will be only 6%. So he thinks that the real return is only 6%. What does Bill believe the inflation rate will be over the next year? So find the inflation rate, find H. So if you use this method, 1 plus 0.13 equals to 1 plus 0.06 times 1 plus h. Okay, so h is equals to 1.13 divided by 1.06 minus 1. Then you can get your inflation rates. For the rough estimation one, more straightforward, 13% roughly equals to 6% plus h. So h is roughly equals to 7% after 13 minus 6. So what is the exact figure here? Very simple, 0.0660 or 6.60%. Okay, so the estimations and the exact one usually not too far around. It's just like round figures. All right, so some students will be asking, can we use, which formula should we use, blah, blah, blah. So when it comes to your exam, if they never stated using rough estimation or using the Fisher equation exactly, do both of it. Okay, do both of it. Okay, do both of it. Now, next question also is calculating Fisher equation. Let's try again. So say you own an asset that has a total return last year of 17%. Total return of 17% means your nominal rate is 17%. If the inflation last year was 2.9%, what was your real return? Find your real return. Rough estimation one, simple. 17% rough estimation of R plus inflation of 2.9. So R is roughly equals to 17 minus 2.9, 14.1%. As for the actual formula, 1 plus 0.17 equals to 1 plus more R times 1 plus 0.029. So R is equals to 1.17 divided by 1.029 minus 1. Then this will give you 0.1370 or 13.70%. This is Fisher, very easy. Anyone got difficulty with Fisher or not? Oh, lesser participants. So Fisher very easy, huh? Okay. Then let's try our last question for today then. So this last question here, it's a bit different from what we have done just now. Okay. So read the question carefully with me. PK software has 7.5% coupon bond on the market. Okay. With 22 years to maturity. the bond makes semi-annual payment. So the keyword here is semi-annual payment. This is the keyword. And currently sell for 106% of par. So they want you to find the current yield, the YTM, and the effective annual yield, which is the EAR. All right. So a lot of weird terms has been using here. So first look at the 7.5% coupon bond. So payment, 7.5% coupon bond, you know, is 7.5% of face value 1,000. So this is 75. 75 per year. But this is semi-annual. So your payment will be split into two. So each time payment is 37.50. Okay, 37.50. Each period is 37.50. All right. Next, 22 years to maturity. 22 years to maturity, but it's semi-annual. So there are 44 periods or 44 payments. So because of semi-annual this keyword, your payment divided by 2, your N times 2. Next, is currently selling. The present value is currently selling at 106% of par. Par is 1,000, so 106% of par means 1060. Okay, so you got payment, you got present value, got future value, got period. The only thing missing is YTM. Okay, so before YTM, number one, they want you to find current yield. But first of all, before find current yield, you can see PV more than FV. This is a premium. Means CR will be more than YTM also. Okay, so the question, first thing they want you to find current yield. Annual coupon payment divided by current bond price. So annual coupon payment is for one whole year, not for period. So it's 75. Current bond price is 1060. So your current yielding here, you will get 0.0708 or 7.08%. Okay. All right, this is current yield. And next, after current yield, they want you to find YTM. So here, financial calculator, payment 3750, 44 PV plus minus 1060, FV 1000, and compute PMT. Sorry, compute IY. So this IY you get is for semi-annual. So the IY you get here is a semi-annual IY. Okay, so you will getting a 3.482%. But this is semi-annual. Yield to maturity, it's supposed to be 1 year. So now you got half of it already, what? So basically this is APR lah. YTM is APR. So your APR is 3.482 times 2. 6.964%. Okay, so this is the thing here. One thing students will always say, sir, if that's the case, why don't I just don't put this, I calculate, I get 6.964, correct or not? If you do, you did not show your payment divided by 2, and you did not show that your n or your period, it's multiplied by 2, then you're not talking about semi-annual. Then you get it wrong, although you get this. Okay, you still got it wrong. So you must find semi-annual first, then only convert into 1 year. This 1 whole year is your APR. So YTM is also APR. Okay, then moving on. After having APR, they want you to find the last one, effective annual yield, which is EAR. So EAR formula, if you can recall, 1 plus APR divided by frequency, power of frequency minus 1. Okay, so if you already know your APR, then easy to find EAR. 1 plus 0.06964 divided by 2, semi-annual, power of 2 minus 1. You'll be getting 0.07085. Correct or not? Let me count. 0.06964 divided by 2 plus 1 power of 2 minus 1. Correct. 0.06964 2 plus 1 minus 1. 0.07085. Correct. Or 7.085%. This is your effective annual yield. Those who use financial calculator, please try. I already told you how to do it last week. And yeah, so this is how a bond question could also be. Okay. And again, these YTM questions, you cannot use scientific calculator. You need to try and error. So for those who use the scientific calculator, you will get this 1060 equals to 3750. 1 minus 1 over 1 plus I, don't know, 44 period, divided by I, plus 1000, divided by 1 plus I, power of 44. So you need to try and error to get this 3.482. Okay, you can first try according to your luck. When you know that the coupon rate is 7.5%, so your YTM should be less than 7.5, but now it's half of it, so definitely it need to be lesser than 3.75%. So you can try when I equals to 3%, when I equals to 3.5, then you can already spot it that is between 3 and 3.5 already. They're going to be challenging to get 3.482 exactly. So in fact, if you can get 3.5%, okay, or 3.5% is considered good enough. Okay, but if you get 3.5% times 2, you get 7%, then of course your EAR might run a bit. It won't be so accurate also. So this is the challenges that you might face with doubt. a financial calculator. So again, my piece of advice to you is, if you are going to major in finance, or if you're going to proceed with the career in finance, so you have 2 more years to go down the road, might as well get a financial calculator that might assist you better. Okay,